Today we're going to solve a business problem for the telecommunications industry using SPSS modeler flows on IBM Watson Studio. First, we just click SPSS modeler flows and add it to our project. There are many ways that you can add SPSS models to your projects. You can do them from examples. You see we've got some here, but today we're going to do it completely from scratch. First thing we'll do is give our model a name, something like customer churn. Give it a description so that our colleagues and collaborators know what this model is doing, and click create. The problem we're solving today is customer churn. We need to predict whether a given customer will churn or stick with the firm. We've got two CSV files here. One contains information about our customers and one contains historical information about whether or not this customer has churned. We're going to use these together to build this model. First, we want to preview our data, and we just click preview. Previewing your data allows you to audit and inspect the data set before you begin modeling, but we also offer tools to shape, transform, and refine your data. Another powerful feature is profile, where you can get more descriptive statistics and information about the distribution of your data before you begin modeling. And this can be helpful for understanding the data set when you make decisions about how you might transform and model the data. Now we've dragged and dropped a merge node. The merge node is pretty intelligent, so you can use it to group and join your data together. Here we choose the key and we use the ID field in order to merge our two data sets, and then we drop a type node. The type node makes it easy to specify which fields you want to use in your model, which fields are targets, predictors, that sort of thing. So what we're going to do is we're going to flag one of our fields, which is churn, and we'll flag it as a target. The other field we want to flag is the ID field. It doesn't really contain predictive information, so we'll mark it as an ID column, and that way our model knows that we don't really want to assign any kind of predictive value to this field. Now that we've prepared the data for modeling, we're ready to go to our modeling nodes. We have many powerful and familiar nodes from SPSS. We're going to use the C5 model. That's a decision tree model which will attempt to form rules about your data that are most predictive of whether or not the customer will churn. You can allow this to happen automatically, but you also can click this box, use custom fields, and here we're only going to choose a subset of our fields for the model, something like gender, marital status, their estimated income, age, and what kind of plan they're on for our telecommunications company. After we're happy with that, we click save, and now we've configured this entire flow for modeling. First, we merged the two data sets, then we chose which fields we'd use in our model, went into the model itself, and then we click run. You can run from the top menu bar as well. What this will do is it'll begin the model training process by running and executing your flow. When it's complete, you'll see this other node down here, and we'll go to view model. The model information page is your model's home page in the SPSS flow. It contains a lot of information about the decision tree itself. For example, the predictor importance. We see that we settled on estimated income as the most important predictive feature, so we'll go back to our canvas and investigate this a little bit more right now. You can interactively generate charts and visualizations easily with the SPSS modeler, so we're going to create a histogram of the estimated income, but we want to color this histogram by churn so that we can get some greater insight into why estimated income might be the most predictive feature for our model. Just drop that node, give it a name, choose which continuous field you want for the histogram, how you want it colored, and then you can run the flow. But before we do that, we're going to export some of our data as a table, and we'll also want to save our model and our predictions in IBM Cloud Object Storage. That way we can persist the data that we've retrieved from this model, and we also can further inspect how the model performs on unseen data. After executing the flow, all of our terminal nodes will be represented on the sidebar panel. That includes our table, our data store, and our histogram. Before we inspect those, we're going to save a new version of the model. That way you can keep track of which version you're working on and also revert to previous versions. Let's take a look at our histogram. You can persist your charts and visualizations either by downloading them or saving them in object storage, and that way your analysts and data scientists can communicate the results of their analysis and their modeling process graphically. Now that we've run the flow, we can see that our SPSS model lives within our project on IBM Watson Studio. We can go back to the model at any time, suppose after communicating the results to our team. Now what we want to do is save the model and deploy it into a production environment. All we do is click save, and we'll take advantage of Watson machine learning to store and deploy the model. Give it a name and click save. Saving the model with Watson machine learning generates another asset in your IBM Watson Studio project. First, we have our SPSS modeler flow, but now we also have a new model asset, which contains a representation of this model in Watson machine learning. We'll have information about the runtime, the evaluation, and whether or not you have any deployments for this model. Deploying a model is just as easy as saving. You give it a name to deploy a model as a web service, something like deploy telco, and a description so our collaborators understand the purpose of the model. After that, IBM Watson Machine Learning will create an API endpoint that you can use in order to get live predictions for your model and use them in an application of your choice. Today, we solved a business problem for the telecommunications industry with SPSS Modeler and IBM Watson Studio.